Ever wondered how it's possible to predict future trends based on past data? Or how to identify the factors that influence a particular outcome? The answer lies in a statistical tool known as regression analysis. In the realm of quantitative research, regression analysis is arguably one of the most versatile techniques available. It serves as a magnifying glass, allowing researchers to explore and quantify relationships between variables, predict outcomes, and uncover underlying patterns in complex datasets. At its core, regression analysis is about modeling the relationship between a dependent variable, the outcome of interest, and one or more independent variables, the predictors or explanatory variables. The primary goal? To estimate the strength and direction of the association between these variables and identify factors that significantly influence the outcome variable. Output. There are a variety of models within regression analysis, each tailored to different research questions and data structures. There's simple linear regression, which examines the relationship between one independent variable and a continuous dependent variable. Then there's multiple linear regression, which extends to include two or more independent variables. For situations where the dependent variable is binary or categorical, logistic regression is the tool of choice. It models the probability of an event occurring based on one or more independent variables. If the dependent variable is ordinal, meaning it falls into ordered categories, ordinal regression is the go-to model. For relationships that don't follow a linear pattern, nonlinear regression is the solution, accommodating curved or non-monotonic associations between variables. Conducting regression analysis involves a series of steps. First, there's data collection and preparation, where researchers gather relevant data and ensure that it's clean, organized, and free from errors or missing values. Next comes model specification. Here, researchers determine the form of the regression model, deciding on the choice of dependent and independent variables, functional form, and potential interactions or nonlinear terms. With the model specified, estimation begins. Statistical software is used to estimate the parameters of the regression model, including coefficients, standard errors, and goodness of fit statistics. Following estimation, researchers evaluate the overall fit of the regression model to the data, using diagnostic tests like the coefficient of determination, residual analysis, and hypothesis tests. Finally comes the interpretation of results. The estimated coefficients and associated statistics are interpreted to assess the strength and significance of the relationships between variables. This step allows researchers to identify predictors of the outcome and draw conclusions based on the findings. In essence, regression analysis is a powerful tool that helps researchers to understand how variables relate to each other and how they can influence outcomes. It's a fundamental part of our ability to make predictions and inform decisions based on past data. So the next time you marvel at a future prediction or a trend analysis, remember the role of regression analysis in making it possible.